All right, so I just want to thank everyone for attending or watching the video. Thank you, Professor. Got to get those congratulations out. All right, so our project is about a novel, low-cost sensor prototype for monitoring temperature during wine fermentation in tanks. Research presentation, which is going to be very similar to what our project is going to be about. My name is Alejandro Quinones, and Jatisha Freeman and Daniel Joseph. I'm just going to talk for them for the moment. No? Okay, here we go. So the abstract of the paper is that this paper is about a multi-purpose, low-cost sensor designed and experimented for a temperature-controlled and monitoring sensor over the fermentation process of wine, communicating real-time data over wireless modules to a mobile device. Designed as a cheaper and easy-to-use temperature control and monitor sensor during the fermentation process of creating wine in small winemakers in Ribera del Duero. It's an area in Spain. The MSP 430 G2553 microcontroller is used as the brain for the prototype, integrated into the motherboard of the system, communicating with the RN42 Bluetooth module through UART interface designed with a wire in a winery in the Ribera del Duero region. Introduction. The fermentation process of wine is exothermic, releasing energy through heat, raising the temperature inside the wine barrel. The microorganisms within the wine grape sugars needs a temperature range near 86 degrees Fahrenheit in order to turn must into wine. If these microorganisms are exposed to higher temperatures than 131 degrees Fahrenheit for more than 5 minutes, they would die and the must will not turn into wine, leading for the reason why temperature control during the fermentation process is needed. Using monitoring systems improves the quality of wines for a winemaker. Controlling the fermentation process of wine is just as important as all other measured parameters for quality of wine. The prototype was designed for several options: Bluetooth, Wi-Fi, Zigbee. Wi-Fi was discarded because the prototype did not need high transmission rate, cost, or processing capacity. The Bluetooth and Zigbee option both have similar network range. The rates of transmission offered by Bluetooth are higher than those of Zigbee. Also, seeing as Bluetooth is popular than Zigbee, more devices are available for the prototype configuration, leading the authors of the prototype to develop the prototype on mobile phone applications. Their authors decided that Bluetooth was the most appropriate technology because Bluetooth's low implementation cost and power, higher transmission, and market rate penetration rate. After analyzing the microcontrollers and sensors needed, a multi-purpose low-cost sensor that sends data through a Bluetooth module was developed to provide winemakers absolute control over the wine's temperature during a mobile device application, displaying a real-time data collected by the prototype. Now, the portable prototype, the parts and connections, description, which is the MSP 430 launchpad, and the microcontroller that the authors use, is actually the heart of the system. Its responsibilities include translating analog information to digital and sending it to its proper location through Bluetooth. This microcontroller is also low cost in consideration that wine companies did not want to spend a large amount on their budget or technology. Now I'm going to hand it over to Darnell, who's going to continue for me. Darnell?
Thank you, Alejandro. I appreciate you. So now we're going to go ahead and just describe a little bit about the integrated ADC and the temperature sensor, right? So when you're talking about the converter, it supports analog to digital conversions configured by 2 core registers, right? When that module prepares and stores a conversion.
Oh, wait. What's going on? All right, there we go.
The data transfer controller is triggered without any influence intervention and stops the CPU to avoid any data bus connection, then resumes once done. The temperature sensor is used with the analogical input to control the sensor. Next slide, please. Right. So within the parts and connections that you have, right, there's also the universal asynchronous receiver or transmitter interface, also known as UART. It's a standard communication port, converts the information measured from parallel to serial, and then once that's finished, communicates with the Bluetooth module and vice versa back to the microcontroller so that you're able to actually get the data to and from the controller the way that you're expecting it to. Now, for the meat and bones in terms of what modules that we were able to use for Bluetooth, right? There was a bunch of deliberation that was actually done in terms of what parts are going to go ahead and be used for this project. You need to look at how big it was, how much power is going to go ahead and be consumed, how easy it was to configure, and overall what's going to be the best for your project in terms of scalability and the way to move it forward. Now, looking at those two or several options in terms of what we needed to go ahead and have for that project, the two obvious choices came down to be the BlueGiga's WT12A and Roving Networks RN42. With some testing that happened, as well as looking at price and other variables, the RN42 made by Roving Networks was going to end up being the choice that was made for this project, mainly due to the fact that it was cost effective, and more importantly, it could be configured for wireless use, which BlueGiga's WT12A did not have at the time. And then as you can see from the previous photo, is an example of the RN42 that we have here. Next slide, please.
God damn. All right. Hold on. All right.
So when you're talking about developing the prototype, right, there are several different types of programs you could have used in order to go ahead and move this project along. Here, we're going ahead and looking at the environment for this prototype is coded in C specifically, which is much better in terms of instead using Java or any other type of language, just specifically for the portion of embedding it into the microcontroller. And Texas Instruments actually created the software that allowed for debugging post installing the drivers for the PC. So after you go ahead and you get those done, looking at scalability, once again, the microcontroller actually can be used without a computer after it's been implemented. And then here's an example of what it kind of looks like in terms of VS Code. Development design of the circuit, right? So using Eagle, right, which stands for Easily Applicable Graphical Layout Editor, the V6 version, developed by Katsoff Computers. That's where you go ahead and you make schematics for what you're going ahead and trying to represent. And in our case, we're looking at the connection scheme over the testbed, right? So when you go ahead and you look at those different components that may be used within our project, what you go ahead and see is that you have both the external temperature transducer as well as the internal sensor that you really need to go ahead and see how they connect with each other. Now, when you look at the total cost of components, right, the figures that you currently see in the photo that are right here are done in euros. So I went ahead and converted them into USD to make it more understandable for those who are currently here in this meeting, as well as you, Professor, who will be watching this. But when you go ahead and you break down all the parts that are going to be necessary in order to replicate this prototype, it roughly comes down to about $59.77, which, if translated from euros, ends up being roughly like 49.60 euros. Or as you can see here, it says 48.83. Some of the things are missing in terms of like little things that you may do. And the main reason why the price may fluctuate is just due to the fact that discounts may be applied per item and time that they're available, as well as some manufacturers may go ahead and state that they want X amount of minimum order in order for you to go ahead and get it. So depending on how big the order needs to be, we'll go ahead and determine what your price is for that. I believe I have one more slide before passing it off to Jatisha. Oh, actually, I think this is Jatisha's slide now.
Yes, so this is just summing up the results and kind of discussing it here. So with the prototype that was developed, it resulted in the correct temperature being recorded, so it worked really, really well. And when we compare it actually to a commercial sensor, the results are almost identical. You can see in the graph here, the green is the commercial sensor and the red is our wireless sensor. So with the commercial sensor, it actually isn't wireless, so you would have to insert it into like the wine barrel to actually get the temperature and everything like that. So it's also not as cost effective as the prototype that we see here. So with Darnell was kind of explaining the price. The commercial sensor is actually way more expensive. So we see here that our prototype actually has a really good advantage over the commercial thermometer that's out right now. Thank you. So in the conclusion, here is a picture of the barrel, and then you can kind of see the sensor over on the right, what it looks like. And then on top of the barrel, it kind of goes inside and it's all set up so it doesn't get ruined by the wine or anything. So that sits on top, and it's actually very small and simple to use. Because as Alejandro was saying, you know, wine companies don't want to spend too much money on technology when their main focus is really having the best wine they can. So this prototype was the perfect balance of quality and price. And we saw that Bluetooth was going to be the perfect wireless communication for the device. Also the microcontroller that we see the name there was very cost effective. The Bluetooth module was also able to be turned off when we weren't using it. So it conserved energy in that sense. And then here's the acknowledgements. The paper was developed by the Recognized Research Group Information Society. So, you know, we see that these people are accredited with what they're saying, with what they did with the prototype. Next slide. Yes, so the references obviously show that they cited their work and they were getting all their information from very reputable sites. So we have about 3 pages of references just showing everything here.
Yeah, I believe that's it. That's all of it.